Let's consider function notation. So function is typically specified as y equal to f of x, where x is the input and y is the output. This may also be written as f of z, where z is the input. Okay, let's for example, f of x equals x square minus 1. Then what would f of z be equal to? Remember, it wouldn't be x square minus 1 because now the input is z. So the output will be z square minus 1. So this f of x here is merely a representation of the fact that if the input is x, then the output is x square minus 1. So the output for this function f of x is equal to input square minus 1. It only represents that, and for representing that we are using the variable x. Typically x is used. We are not going to write output and input, they're too big to write. So that's why f of x is typically used. And therefore it means that if you encounter f of z, the output will be z square minus 1. If you have to answer what f of x square is, then the output will be x square minus 1, because it's input square minus 1. Input was x square, so square of the input is x square square, which is going to be x power 4 minus 1. That's going to be f of x square. So therefore the meaning of this function is essentially in f, not f of x, not f of z. F represents the meaning of this function. Okay, f of x merely represents the input-output relationship, as we already talked about. Okay, so let's consider composite functions, or functions that are in cascade. So there's fx followed by g of x. The input x goes into f of x. The output of that function goes as an input to another function g of x, and then g of x produces an output based on whatever it got as an input. So that entire thing, the entire overall function, is called a composite function, g of f of x. Now writing that in this way, it's not wrong, but it may be slightly confusing. So we can write it in a better way, like this. Although in books you will still find it this way, so you must understand that you must understand its true meaning, which is something like this. Okay, that x goes into f. You could represent the function f as just f with plain brackets, no x's in there. Okay, so x goes into f. The output is f of the input. The input was x, so the output will be f of x. That output f of x goes as an input to the function g, and the output of the g function will be g of the input. Now the input of g was f of x, so the output will be g of f of x. Okay, so that is a slightly better way of representing and understanding composite functions. Okay, thank you.